Hello everyone, and thanks for watching Edupedia World Videos. In this video, I will show you the solutions to the problems in the physics part of paper 1 of the 2015 JEE Advanced question paper. Now we are done with the multiple choice questions and we move on to the column questions. So the first one is about radioactivity. So let me just write down the relevant equations. You need to remember the most important of these equations, that is uranium-235 fission. The equation for that is 235U plus 10 neutron. A neutron bombards this and this becomes 14456 boron plus 8936 krypton plus 3 neutrons plus gamma rays. Then the cobalt decay, that is 6027 cobalt goes to 6028 nickel and gives an electron and an antineutrino. Then the most important standard equations of all, N goes to P plus E plus antineutrino, or P goes to N plus positron plus neutrino. And also, you don't really need to know the exact equations for the sun, but you need to know that hydrogen adds another hydrogen and converts to deuterium with a positron and a neutrino, and this deuterium through a series of other reactions ultimately becomes helium. So in the sun, what ultimately happens is hydrogen fuses into helium, and this helium actually releases one more hydrogen atom, so that keeps the reaction going. So now let's look at the options. Nuclear fusion. In nuclear fusion, there is energy produced in the stars, that is through the nuclear fusion. Hydrogen and hydrogen become helium, and in that process neutrinos are transmitted as well, right? So for option A, the answer will be R and T. All the others are incorrect. Option B, fission in a nuclear reactor. In that case, that is what happens. There is an absorption of thermal neutrons by 235. That is how nuclear fission happens. And you do need to know the mechanism of a nuclear reactor, and it does involve heavy water. There is no nuclear fission in cobalt nucleus, and there is no neutrino transmission in nuclear fission. So the answer for option B will be P and S. For option C, we want beta decay. So neutrino transmission does occur in the standard beta decay, which is proton goes to neutron plus positron plus neutrino, or neutron goes to proton plus electron plus antineutrino. Those two reactions do involve neutrino emission. And also the decay of cobalt nucleus is a beta decay. There is no electrons decayed in the absorption of thermal neutrons, nor are they given out in the energy production of stars. Positrons are given out in that. So the answer to option C will be Q and T. For option D, we want gamma ray emission. So we just again look at the reactions, and gamma rays are emitted in nuclear fission, that is 235 uranium nucleus being rubbed. Also it occurs in cobalt 67, and also it occurs in energy production in hydrogen converting to helium. So the answer to this question would be P, Q and R. And finally we have the last question that is left. This question, we are given a bunch of potential energy functions and we are asked to find out certain properties of that. So the first potential energy function, we can differentiate it right away and we can get the force. The force will be minus du by dx, that will be minus u naught 1 minus x by a whole squared into minus 2x by a. We see that it's 0 at x is equal to minus a, 0 and a. So the first three options are correct. Then we want to find out if it experiences an attractive force. So if x is positive, in that case the force is positive. So there is no attractive force in this case, right? There is a repulsive force, in fact, away from the origin. Also we want to find out if a particle with total energy u by 4 can oscillate about x is equal to minus a. So let's calculate the value of u at x is equal to a and minus a. At x is equal to a it is 0, at x is equal to minus a it is 0, and x is equal to 0 it is u naught by 2. So here it is 0, 0, here it is u naught by 2. And we know all these three are minimas because the force is 0. So this has to be a minima, something like this. And since the energy u naught by 4 is less than u naught by 2, it will be able to have simple harmonic motion in this region. So the answer to the first one will be P, Q, R and T, not S. In the second part, u is u naught by 2 x by a whole squared. So let's just calculate du by dx because we won't bother with this minus sign. We only need to find out where it's 0 anyway. So du by dx is u naught x by a squared. So it is not 0 at a or minus a, but it is 0 at x is equal to 0. So it does have q. Now let's look at the other two options. For s, it has to experience an attractive force. So du by dx is this, minus du by dx is this, which is the force. When x is positive, it's negative, and when x is negative, it's positive. So it does experience an attractive force. So s will be an answer. How about t? Can there be an oscillation about x is equal to minus a? No, because x is equal to minus a is not an equilibrium position. Oscillations can only occur about equilibrium positions. Let's look at question C. Option C. Option C is u naught by 2 x by a whole square e to the power minus x by a whole square. So du by dx will come out to be, it will have many terms, u naught x by a squared times e to the power minus x squared by a squared plus u naught by 2 x squared by a squared e to the power minus x squared by a squared into minus 2x by a squared. I've just used the product rule. I can take u naught x by a squared e to the power minus x squared by a squared common, and it gives me, I'll just rub some stuff here. Yeah, so it gives me, this becomes equal to u naught x by a squared e to the power minus x squared by a squared. This term will be 1 minus, I'll take 1x common, 2 will cancel, to minus x squared by a squared. So again we see that it is 0 at x is equal to 0, a or minus a. So P, Q and R are automatically correct. Let's look at the other two options. Does it experience an attractive force? So if x is, this is the derivative, right? So force will be the negative of this. So if x is slightly positive, this is negative, and if x is slightly negative, this is positive, because this is the only thing that determines it. Everything else is positive. So indeed S is also part of the answer. What about T? For T, we need to know if it can have simple harmonic motion. So even though it is an equilibrium position, let's look at the values of u in this case. So when x is equal to 0, u is 0. When x is equal to a or minus a, u is equal to u naught by 2a. So here it is 0, a or minus a. It has a particular positive value, u naught by 2a. Right. So obviously it has to be something like this. Minus a and a cannot be stable equilibriums. You can try to double differentiate it and look at the sign as well, but I am showing you an easier way. If we know at these 3 points the derivative or the slope becomes 0, and we know the values at these 3 points, there is no way possible that this could actually be a minima, right? So T option will not be correct, since even though it is equilibrium, it is not stable equilibrium. Let's look at the last one. If we differentiate the last one, we get du by dx is equal to u by 2 1 by a minus x squared by a cube. It is 0 at a and minus a, not 0 at x is equal to 0. So P and R will be correct. What about attractive forces? This is positive, so minus of this will be negative. We know that if x is positive, this is towards the center, it is negative. So it will indeed experience a restoring force, and it can execute, and it will experience a restoring force. As per simple harmonic motion, we need to double differentiate and see the sign. So d2u by dx squared is minus u naught x by a cube, which is positive when x is equal to minus a. So it can execute simple harmonic motion about x is equal to minus a. So t will also be the answer. Okay. That completes the solutions for paper 1 of JEE Advanced. Thank you.